Right. So a family of graphs, right, is a group of functions that basically look the same when you graph them. So for example, all, linear graphs, all linear functions, that's a family of functions, right? And so on. In a family of graphs, you have always a parent function, and that's basically the most basic, like the default case that graph can be drawn, right? And then you start from that and you transform it and you create others in the family. So the first type of function we're going to talk about is a constant function. A constant function has an equation that looks like this: f of x equals a. For example, f of x equals 5, y equals -3, and so on, right? We already started graphing things like this on the last quiz as well. And if you have a graph that looks like a function that looks like this, the graph will always be a horizontal line, right? Remember, it's y equals f of x equals, so it's a horizontal line. Okay, remember, these are all functions, so we can't have a vertical line because that is not a function. All right, the next, okay, so what is the domain? All real numbers. And what is the range for this one?
1.
It's just 1, right? It's just, whatever the a value is. Okay, in grading your quizzes, please remember to put your domain in curly brackets, always, always, always. Okay? Yeah.
What's like
A is any number. It could be any number. Like f of x equals 5, 3, 7, 9.
Okay, and then is the f of x, like, was y equals 3, that's not like related to the f of x, right? I thought f of x
It was an example. Right, so these are different examples. It could be, okay? All right, next is the identity function. Next is the identity function, f of x equals x, right? So that gives you a line. That's a linear function. Okay, the domain for all of these functions is going to be all real numbers, and the range is always going to be all real numbers. All right? So next we have an absolute value function. This is how the parent function looks. And an absolute value function always has a corner like this. Okay? So now the domain is always going to be all real numbers, and the range is always going to be y is either greater than a number or y is less than a number. So in this case, it's y is greater than or equal to what? 0. Okay. Lastly, we have a quadratic function where you have f of x equals to x squared. So anytime you've got an x squared as the highest exponent, that's a quadratic equation. The graph for it always looks like this. That shape is called a what? A parabola. And the domain for all parabolas is always all real numbers. The range is always y is greater than or equal to a number or less than or equal to a number. In this case, greater than or equal to 0. Okay? All right. Transformations of graphs. Now you can take each of those graphs and you can move them horizontally, vertically. You can flip them. You can make them wider, narrower, right? All of that comes with, differences in the way the function looks. So look at this one. This versus this. This is the graph of the parent function. This is the graph of an absolute value function with a transformation, right? Okay. So let's graph an absolute value function. Whenever you want to graph, this first time we're going to do a table, and then we're going to see how else we can do it, right? So whenever you want to graph with a table, you want to make sure to pick points that are positive, negative, and 0, right? So for example, I could do, -2, -1, 0, 1, 2. So if I put -2 into the function, what do I get? 2. And -1 gives me 1. 0, 1, 2. So now at x equals -2, I have 2. -1, I have 1. 0, 1, 2. Then I take a ruler and I draw lines through these. Okay? And that's how the absolute value function looks. It's got to be a straight line. Okay. Now, how else could we have drawn this? Because this is a straight line, we know that once you have a point, you can just do a slope, right? You could go up and over and you can graph a line. So you don't have to pick points every single time. So this looks like y equals x, right? What is the slope of that line? 1. And here, -1, right? So basically, another way I could have drawn that is I put that center point, that's called a vertex. And then from the vertex, I pretty much go with the slope. So in this case, I go up 1 over 1, up 1 over 1 to the other side. Okay? And that's how I can draw it in a much more quickly or swiftly. Okay, now let's talk about some transformations. The first type of transformation or change is a translation. A translation just moves the graph up, down, right, left. You don't do anything else to the graph. You just take the solid graph and you just move it up, down, right, left. That's it. When a constant k is added to a parent function and it looks like this, the graph moves up k units. When a constant k is subtracted, like f of x minus k, it moves down k units. All right? So take a look at this. F of x was absolute value of x. I added +3. That will move the graph where? Up 3 points. So remember, our point of interest is that vertex. So instead of it being at the origin like the parent function, now it's just going to have moved up 3 points. 1, 2, 3. Okay? From there, I'm going to graph an absolute value function and I'm going to go with slopes. So I'm going to go up 1 over 1. All right, and then up 1 over 1 this way. And now I take a ruler and I draw. Yeah.
Could you also like just do the absolute value first and then take that number and do +3? Or no?
Well, to graph, that doesn't matter. Like, so you just move and then go from there. Okay, now what about this one? Absolute value of x minus 4. Where is that going to move the graph? Down 4. So now I'm just going to go down 4. I'm going to go up 1 over 1, up 1 over 1, and here. I just want to put another point here so I can scale it. Oh, okay, see, that wasn't a straight line. That's no good because I am not using a ruler. Use a ruler. Okay. The point of Algebra 2, yeah, one sec. The point of Algebra 2 is this. By the end of it, if you're walking down the street, right, and you see a white billboard, and on the billboard, it just says f of x equals absolute value of x minus 4. That's all. If you look at that billboard, you should be able to visualize, oh my God, that's an absolute value graph, move to the 4, right? You should be able to come up with it like this, okay? So we're not, in Algebra 2 Honors, we're not really concerned with like the nitpicky, if x equals 2, what is y equal, like we really should be able to do a precise graph seeing the big picture, okay? Yes, and then
would you create like tests and quizzes? Would you have rulers for?
I have rulers here.
Okay.
If you don't have a
Thank you.
ruler, if you forgot your ruler, I have a ruler here.
Okay.
But just in case,
Ruler
like there was a
also.
ruler
Yeah.
thief and they stole my ruler, you know, like
Always have.
have a little one with you just in case. Yes.
And so when we do these problems, the vertex is always at 0, right? So like
For the default case, it's always at 0.
Okay.
And then it moves from there, yeah.
On test or quizzes, are you gonna want us if to write by hand and like not mathematically like explain what we did to the graph?
You'll see. You'll see. Can you guys put away the calculators for a minute? Yeah.
So if you have a number instead of x, then would you start at that number and then?
There won't be a number. There has to be an x because it's an equation. Okay. So now, when a constant, we call it h, is added to a parent function, and the result is f of x plus h, we go left h units, okay? So now look at this one. It's f of x plus h. So now an h is added to the variable, right? But we go in the opposite direction, left. Why is that? Because you always take the stuff inside, set it equal to 0, x equals negative h, so it moves in the opposite direction. When a constant h is subtracted from the variable, it moves right? So the opposite. So take a look at this one. I have f of x equals absolute value of x minus 6. Because this 6 is being added to the x is horizontal, right? So it's got to move horizontally, right? But now which way is it going to move? Left or right? Right. Opposite of this sign. And again, the idea behind it is you always take that stuff inside, set it equal to 0, and then x is positive 6. So it's here. And then from there, same situation. I go up and over, up and over. Okay?
And the slope of these equations is always 1.
So far. You're fast forwarding a little bit. So hang on, let me teach everything and then everything will be self-explanatory. I know it's your first time taking Algebra 2. It's not my first time teaching Algebra 2. If I had to count the number of like Algebra 2 sections I've taught in over like 20 years, I don't even know, like there were years that I taught 3 sections of Algebra 2, right? So, I mean, imagine how many times I've said these exact same sentences, maybe like 100. So I know your questions before you're even going to ask them. No? Okay. All right. Fine. And as silly or out of left field you think your question is, trust me, I've gotten the same exact question at least once before. Yeah. Okay, so where is this going to move our graph? The plus 2 moves it which way? Left 2. And the 4? Down 4. So from the 0, I go left 2, down 4 to that point right there. Okay, so before we even graph then, can we figure out where the vertex is going to be? It's going to be where? At -2, -4, right? If I were to ask you, where is the vertex, you would be able to tell me. So from here, I go up 1 over 1, up 1 over 1, boom, boom. Yep. Okay.
Why does the -6 move it to the right and then the...
Because we talked about that here. Remember what we said over there. It's the opposite sign. Okay. Reflection. When you have a reflection, the graph basically flips over a line of reflection. But I never say the graph flipped. That is not what a sophisticated math student would say. We would always say there is a reflection around the x-axis. Okay? So, or the y-axis. When a parent function is multiplied by -1 and I get negative f of x, then I have a reflection of the graph in the x-axis or around the x-axis. When the variable is multiplied by -1 and I get f of negative x, then I have a reflection around the y-axis. Okay, so take a look here. F of negative absolute value of x. F of x is negative absolute value of x. Now, has there been a translation left, right, up, down? No. So the vertex is where? 0, 0. So I put the vertex at 0, 0. But now it's going to face down. So instead of going up and over, I'm going to go down and over. All right? So I go down and over. The vertex stays the same because there has not been a translation. Down and over, down and over. Okay? Now, take a look at this one. I've got a whole bunch of stuff happening here. I have a reflection, but I also have some translations. The +1 moves it where? To the left. The 3 moves it where? So what's the vertex?
Up.
Negative 1 and negative 3. Negative 1 and negative 3. 1, 2, 3. But there is also a reflection around the x-axis. So what am I going to do? Down 1, over 1, and so on. How cool is this? Right? Yes, Aiden.
Could you clarify when it's a reflection over the x-axis and when it's over the y-axis? I'm a little confused.
Okay, so with the absolute values, I have to admit it's a little bit confusing. So when you have a reflection around the x-axis, you know, the graph was like that, and now it looks like this, right? That's a reflection on the x-axis, okay?
Isn't that the y-axis?
No, the y-axis, because it flips around the x-axis. Like the x-axis, it flips around the x-axis. If there was a reflection around the y-axis, suppose there was an absolute value here, now it would go, you know, the other way, right? There was like a horizontal reflection like that.
So what would happen to make it like that, like in the equation?
The negative, the x would be negative.
Inside the absolute
Yeah.
value?
Yeah,
Okay.
yeah. Uh-huh.
But isn't that just a shift?
Well, for the absolute values, yes, but if it was another graph, no. If it was like a more...
linear graph, it would just
Right.
it would become a negative
Right.
slope or
Mhm.
something.
Okay, next let's talk about dilations. Dilations are when a graph will shrink or enlarge, make it wider or narrower, right? When a function is multiplied, by, I didn't mean to do that. All right, so it's okay. When a graph is multiplied by a coefficient greater than 1, it's a vertical stretch. It's like if I were to take this absolute value and stretch it upwards, what would happen? Would it seem narrower or wider? Narrower. Okay, that's if we multiply it by a factor other greater than 1. If I multiply by a factor between 0 and 1, 1/2, 1/3, then it would look like it's a compression. So I would press downward, and what would happen? Would it look wider or narrower? Now it would look wider, right? Because like you press down and like it bulges this way, okay? So take a look at this one. Now I have f of x equals 3x. Where is the vertex now? Has it moved anywhere? No, so it's still at 0, 0. But now, because it's 3x, instead of going up 1 over 1, I'm going to go up 3 and over 1, right? So the y, the vertical, will be multiplied by 3. So up 3 over 1. And then up 3 and over 1. Here, here. Next one is a half x. So vertex is still at 0, 0. And now I'm going to go up 1 over 2. And it's going to be wider. Okay, hang on. Okay, all right. So now let me do these. Let's take a look at these now. Let's just summarize. Okay, now that everything is fresh in our mind, let's summarize. Whenever you have f of x plus h, what happens to the graph? It moves, right, it moves left. How much? H units. Okay, so moves left h units. So when I could give you an equation and say describe the transformations, and so you would have to say this moves left 6 units, it moves down, blah blah blah. So this one will move to the right h units. F of x plus k will make the graph move where? Up k units. What about minus k? Down k units. Okay, write this stuff down. What's negative f of x? It's a reflection around the x-axis. Good.
Oh, I thought.
Reflection around x-axis. What's f of negative x? Reflection around the y-axis. Okay, if you have a times f of x and a is greater than 1, then it's a vertical stretch, right? Right, so we say it's a vertical stretch. I'll take questions in a second. If you have a times f of x and it's between 0 and 1, it's a vertical, not stretch, compression. Right? So we have to, this is called language of the discipline. We have to use words that are, technical words, right? All right. Now, if I have f of b of x, okay, this is harder to see, but now it's also a stretch and a compression, but if it's happening to the x, what kind of compression or stretches? It's a horizontal, right? What would this be? A horizontal what? Stretch, right? Good. Now we're laying the framework, okay? Later on, okay, when we get to quadratic, cubic, rational functions, these are going to seem more and more obvious, but we have to lay the groundwork right now. So it's a horizontal what? Stretch, this one. And this is a horizontal compression. Okay, and we're gonna stop here today, okay? And we're gonna do quadratic functions next time, okay? So